does get through the filtration barrier, but not much. And that which does get through tends to be handled pretty well by the proximal tubule. But all of the electrolytes do get filtered very easily. Sodium, potassium, chloride, bicarbonate, they will go from the capillaries right into the kidney, right into Bowman space. Glucose, urea, they go from the capillaries right into Bowman space. So tomorrow, when we talk about filtration, I'm going to talk about freely filtered substances. And this is how the kidneys work. So they filter a lot of that from our blood going right into Bowman space so that all along these nephron segments that is traveling, it processes them. It either reabsorbs them back into the body, can secrete them, can reabsorb and secrete them, so that by the time we finally urinate, that urine is just perfect for that the rest of the body fluids to maintain homeostasis, maintain all of the electrolytes to where they should be, maintain the osmolarity to where it should be, the sodium concentration to where it should be. And so that's how the kidneys basically work. And so we'll talk about that stuff in detail as we go through. There's one other thing I want to say before I want you to answer these questions right quick. The blood flow to the kidney. What did Dr. Benjamin say about how much blood flow, how much of the cardiac output goes to the kidney? Yeah, it's about a quarter. It's about 25%. So that alone tells you what about the kidneys. The kidneys are small. Okay, they're about that size. It's the size of your clenched fist right there. So they're small organs. But the heart pumps out a cardiac output of what, 4 or 5 liters a minute? About a quarter of that, maybe a little bit more, goes to the kidneys during rest. So that tells you that the kidneys are important. Okay, they're processing a lot of the blood continuously. So as long as we have good kidney function, then the body fluids are going to be normal, and all of the cells of the body are going to be bathed with the proper concentration of electrolytes and nutrients that they've got to have. Okay, so once kidney function begins to go down, lots of things can happen. Okay, let's go ahead and answer these questions right quick. Okay, again, a quiz on Friday, and they'll come from these questions here. Filtration occurs at the ureter, proximal tubule, renal corpuscle, minor calyx, or major calyx. Okay, good. The renal microcirculation flows in the direction of afferent arterial to glomerulus to efferent arterial, efferent arterial to glomerulus to afferent arterial, glomerulus to afferent arterial to efferent arterial, efferent arterial to afferent arterial to glomerulus, afferent arterial to efferent arterial to glomerulus. If any of these questions do not make sense or you think they're poorly stated, go ahead and say so that we can clear that up. Or I can tell you why you're wrong. Okay, so this is just the basic functional anatomy that you need to know. Superficial nephrons have long loops of Henle, small glomeruli, long loops of Henle, large glomeruli, short loops of Henle, large glomeruli, short loops of Henle, small glomeruli. Their glomeruli are in the medulla of the kidney. Okay, all renal corpuscles and all glomeruli are in the cortex of the kidney. Okay, so they're all in the cortex. Don't have any in the medulla. Just the juxtaglomerular nephrons. These juxtaglomerular nephrons serve basically a different function than the superficial nephrons. And the different mammals have a different number of superficial versus juxtamedullary nephrons. And it's basically comes into play when we talk about urinary concentration and how we actually conserve our fluids. And we'll talk about that later on next week. Principal cells transport sodium and exist in the proximal tubule, transport hydrogen and exist in the proximal tubule, transport sodium and exist in the collecting duct, transport chloride and exist in the thick ascending limb, secrete renin and exist in the afferent arteriole. I know you've heard about renin, angiotensin, and aldosterone, right? So this juxtaglomerular apparatus becomes important in that mechanism, and we'll talk a lot about this mechanism of renin-angiotensin and aldosterone in the next few lessons. Okay, the JGA, juxtaglomerular apparatus, consists of granular cells, extraglomerular mesangial cells, and macula densa, granular cells, extraglomerular mesangial cells, and podocytes, granular cells, proximal tubular cells, and macula densa, intercalated cells, extraglomerular mesangial cells, and macula densa, granular cells, extraglomerular mesangial cells, and IMCD cells. Okay, simple enough. The filtration barrier consists of endothelial cells and principal cells, mesangial cells and glomerular basement membrane, podocytes and granular cells, podocytes and proximal tubular cells, glomerular basement membrane, and podocytes. I've got 2 of the 3 in there. Which of the following in the glomerular filtrate indicates glomerular disease? Okay, if you can sample, the filtration barriers from the capillaries into the glomerular filtrate. That's the initial part. That's where Bowman space is. Okay, so I talked about freely filtered substances, what should get filtered, what shouldn't get filtered. All of these are plasma concentrations of substances. So if you sample the fluid from the glomerular filtrate and measured the concentration of these substances, which would tell you whether or not there is a kidney disease. Sodium concentration on 145 milliequivalents per liter, chloride concentration on 105 milliequivalents per liter, potassium concentration 4.5 milliequivalents per liter, and albumin concentration of 4.5 grams per liter, or a glucose concentration of 75 milligrams per deciliter. Okay, the anatomy of the lower urinary tract is when we talk about micturition. Anatomy of the lower urinary tract and the nervous innervation, that is urination. I'm going to cover that in GI physiology when I talk about the mechanism of urination and the mechanism of defecation. Okay, that is very exciting. You just can't wait until we begin to talk about those mechanisms. Okay, so that's an easy lesson day, functional anatomy of the kidney. Okay. Tomorrow we start talking about the mechanism of glomerular filtration and renal blood flow. Okay, that's not so easy. Okay, that's going to be a little bit more difficult. Okay. Any questions yet on anything that I've covered so far? Yes, sir.
What was the answer to the first question?
The answer to the first question. Yeah, where does filtration occur? Let's go back. That's an important one right there. Okay, filtration occurs, the ureter, true or false? Proximal tubule, true or false? False. Renal corpuscle, true or false? True, yeah. That's where it occurs. Okay. So that's where the glomerular capillaries are. Okay. So glomerular filtration is what we call it. Glomerular filtration rate is what we'll talk about tomorrow. How fast, basically, does the fluid filter from the glomerulus into Bowman space? That's the glomerular filtration rate. That is perhaps the most important indicator of kidney function. I'm going to talk a lot about that. Okay? Anything else? Okay, thank you very much. We'll see you tomorrow.